So in the previous video, we talked briefly about how to name binary acids. They're acids that have a hydrogen at the beginning and a non-metal attached to it. And they're binary because there's only two types of elements. Now we're going to talk about acids that have an oxygen attached to them. Those are called oxyacids. So to name an oxyacid, it's a little more difficult than a binary acid because once you determine it's an acid and then determine it's an oxyacid, so you know what side of your flowchart to look at, once you determine it's an oxyacid, you need to ask yourself one more question before naming it. Not, why did I take this class? But you need to ask yourself, what is the name of the oxyanion, of the polyatomic ion that has oxygen that's attached to that hydrogen? And the reason why you have to ask yourself what that name is because the name of that polyatomic helps dictate the name of the oxyacid. Specifically, if the oxyanion attached to that hydrogen ends in "ite," if it ends in "ite," then the name of the acid is going to end in "us" acid. So for example, if you had phosphite, the ending name of that acid would be phosphorus acid. So the names of acids that have an oxyanion that ends in "ite," the acid name would be "us" acid. If your polyatomic ends in "ate," if it ends in "ate," then your acid name is going to end in "ic" acid. The way I like to remember that rule is that if you eat too much, if you ate too much, you feel ick. So, however that helps you, however you can remember the rule that if you have an oxyacid, if the polyatomic attached to the hydrogen ends in "ite," then your acid name will end in "us" acid. If it ends in "ate," then it ends in "ic" acid. And so this table from your text lists some examples of oxyacids. So looking at these are all oxyacids because they have a hydrogen at the beginning, a nonmetal, and an oxygen. You'll also note that with oxyacids, with the names, there's no hydro at the beginning, right? No hydro. That prefix hydro is reserved only for binary acids. That's an important point to remember. Okay. So no hydro at the beginning of oxyacid names. All acid names end in acid. For oxyacids, that acid name is dictated by the name of the polyatomic attached to the hydrogen. So for example, HNO2. The polyatomic that's attached to that nitrogen, if I get my pointer here, the polyatomic attached to that nitrogen is NO2 negative, which if you remember from previous chart in chapter 5, that is nitrate. Nitrate, it ends in "ite." So my acid name is going to be nitrous acid. So you can see here from this table that the "ites" end in "us," the "ates" end in "ic." So these are some of the more common oxyacids that you will encounter in this course. You should know them, you should know this rule, and you should also be able to apply this rule for naming oxyacids, even if I was to give you the name of a polyatomic anion that you hadn't seen before. So for example, arsenite. That's not one you had to memorize, and I would not expect you to. But if I was to tell you that this is arsenite, and this is its formula, and I wanted to know what the name of that corresponding oxyacid is, well, my polyatomic anion, it ends in "ite," so my acid name is arsenous acid. The "ites" end in "us." So that is the last part of nomenclature. In the next video, which will be the last video for this chapter, we're going to talk about, now that we know how to name different classes of molecules, we're going to talk about how can we calculate how much a molecule weighs.